Hello. So let's see this problem of a solid. So this is the problem number 1. Now it is given that a square prism with side of base. So base edges is given and base edges is 40 and axis is 70 mm is resting on one of its corners of its base on HP with longer edge containing that corner inclined at 45 degrees to HP. So when it says that the longer edge containing that corner, that means it is the face edge. So let us first mention the solid is a square prism. That means the base is a square. So it is a square prism with sides known to us, and one condition is there: base corner on HP. So to start with, then we will put all the base corners or one of the bases on HP. So in that case, the top view will come out to be a square and it is a corner condition. That means we'll draw the square with its diagonal parallel to the reference line so that we can tilt it about the corner. So to start with, so first we draw the reference line. XY. So this is the reference line XY. And first I draw one projector. Right? Now that means the top view will be a square and it will be at equally inclined condition, then only, and the corresponding front view will be a rectangle. Right? So this is how. So in the front view we will be able to see the axis length, and in the top view the true shape of the base. So I mark a point. So this is supposed to be the diagonal. So to draw that square, so in this condition it will be an equally inclined condition. That means two sides will be inclined at 45 degrees. Right? So this is supposed to be one side, this is supposed to be the other side. Now the base edge is given 40, so from here we measure 40 mm. Right? I take this distance 40 compass, so I mark it. So yes, we have got the perfect square. So we got these four corners of the square. Now we will make the base prominent. So we will make it dark. So we get this as the base. And now we project so this midpoint will be the axis of the solid. So I project. So this is the axis line which we are showing. So this is how we represent the axis line. And this is the right, and axis length is 70 mm. So I take 70 mm. So this will be the top base of the solid. So here I get the front view of the solid. Now, in this case, what will happen is this is the front view. So when we are looking at it in this direction, this face edge, which is perpendicular to HP now, will be visible in the front view. So this edge is going to overlap the axis. So in the front view, we are not able to see the axis. So if you imagine, you will see these two faces to be inclined. Now it is matter of giving the name, right? So first we give name as A, B, C and D. Now A, B, C, D, this name we have given to the top base. So this is A dash, D dash comma B dash, and this is C dash. So when you are looking from the top, we will be able to see the top base first, and the bottom base is hidden. So I'll give name correspondingly 1, 2, 3 and 4. So numbers as the lower base and alphabets as the top base. So I get this as 1 dash, this as 4 dash, 2 dash, and this as 3 dash. So see, by giving separating the name nomenclature by alphabets and number, it will not create any confusion. Then if we say alphabets, that means it is the top base. If we say numbers, that means it is the bottom base. And if it is an alphanumeric, that means it is a face. So ABCD is top base, 1 2 3 4 is bottom base. So if I am saying A dash 1 dash or A1, D4, B2, C3, these are the face edges, right? Now it is said that it is resting on one of its corners. That means we will tilt this solid in this direction, right? So that it rests on corner 3. So this is going to be lifted up, right? So the bottom base is going to get lifted up this way, and the solid is going to rest on the corner 3, and it says that the longer edge containing that corner. So the longer edge contained by this corner will be C dash 3 dash, because C2 and 3 2 and 3 4, they are smaller edges. So longer edge at this corner is only the face edge. So when we tilt it, we are not changing its relation with VP. So it will be the same rectangle or the same front view we are able to see. Only thing will be that it is getting lifted, or the solid is getting tilted by the given inclination, that is 45 degrees. So inclination to HP, that means here in this case theta of the axis is given as 45 degrees, right? So we move ahead and mark one point, and we measure 45 degrees from here. So again, in case of solid, we cannot superimpose the drawings. So I measure 45 degrees and I draw a construction line, and I have to reproduce this same rectangle here, right? So we take this face edge distance, which is definitely 70. In case of prism, always the face edge length will be equal to the axis length, right? So, and the base is perpendicular to face, so I can simply draw line perpendicular to this 45 degrees which we have drawn. So we are here producing the same rectangle. So I take this base, so the base has got lifted up, right? It's interfering in the drawing, so I'll just erase that portion. So thus we get the condition of the solid, tilted condition of the solid. So you can see the base has got lifted. So we'll mark this face edge as well. So this is 3-1 dash, this is 4-1 dash, 2-1 dash, this is 1-1 dash, this is A1 dash, D1 dash, comma B1 dash, and this is C1 dash, right? So now we drop the projectors for the top view. So in this problem only one inclination of the axis is given. So now we'll drop projectors from all the corners. So this prism solid will have 8 corners, 4 of the top base, 4 of the bottom base. So we project all these corners for the final top view. So now we will drag the projectors loci of all these 8 corners parallel to the XY line for the final top view. So this is for B2, this is for these 4 corners, and this is for these 2 corners. So now we will give the name. So projector of 1, locus of 1. So this will be 1, 1. Projector of 2, locus of 2. This is 2, 1. Projector of 3, locus of 3. 3, 1. Projector of 4, locus of 4. So I get 4, 1. Then projector of A, locus of A. So this is A1, B1, C1 and D1. Now whenever we get the points in the top view which are distributed, in case of solid, see, when we look at a solid, of course always the border of the solid is visible. So that means what we will do is we will join all the outermost points, that means the points on the perimeter, whatever distributed points we are getting. So all the points which are at the perimeter, we will simply join them with straight edges. Now this is a prism, so all the edges are straight edges. So we will first join all the corners which are at the periphery, and then we will take the decision which edges are visible and which are not. So the edges which are visible, we will be joining them with solid lines. So that is why we have joined with the solid lines. And the edges which are hidden, we will join them with the help of dotted lines. Now this view what we are drawing is the top view, right? So that means we are looking at it from the top. So if I am the observer, I am standing at the top and looking at the solid, the dot, right? So I am getting this view. So when I am standing here and looking at it from the top base is visible to me, right? So if the top base is visible to me, that means all the edges of the top base will be visible. That means A, B, C, D, they are visible. So A, B, C, D, they will be solid lines. So out of which BC and CD are already taken care of in the first step. So in the second step, I'll be joining then the remaining two base edges. Now when we are looking at it from the top, the bottom base is hidden below the solid. So that means the remaining bottom base edges which are not drawn here, they are hidden. So that means 2, 3 and 3, 4, they are hidden. So we will represent these hidden edges with the help of dotted lines. So these type of lines are called as dotted lines. So you will make sure that when you are drawing these dotted lines, they will be uniform. So usually the length of these small lines are around 2 to 3 mm and the gap is of 1 to 2 mm approximately. We need not measure it. So you have seen how I have drawn it. Thing is that you need to take care that this is uniform. So first step what we did, we have joined the outermost points. This is the first step. Second step is to draw the bases, right? And while drawing the bases, we will identify which one is visible. So when we are drawing the top view, we are looking at it from the top. So top base is visible. So visible base is solid and the bottom base is hidden. So remaining whatever base edges are, they will be joined with the help of dotted lines. So some edges will be taken care of in the first step. We will keep them as it is. We will not disturb them. Now third step is to draw the face edges. So face edges are A1, B2, C3, D4. So we'll check what are the face edges already drawn. So A1 is not drawn, B2 is taken care of, C3 is not drawn, and D4 is taken care of in the first step. So let us start with A1. So this is A and this is 1. Now we will apply the fundamental as on A both solid lines are coming. That means A is visible, and on 1 also solid lines are coming. That means 1 is also visible. So if 1 is visible and A is visible, that means definitely A1 is visible. So A1 will be a solid line, right? B2 is taken care of. Now C3. Now C is visible, but 3 is not visible. So if out of the two, if any of the point is hidden, that means that edge will be hidden. So even you can check it when I am looking at it from the top, the edge C3 is completely below the solid, right? So that means C3 is hidden. So we will join C3 with the help of dotted lines. And this much portion is overlapped by A1, and remain the fourth face edge is D4. So D4 is already taken care of. So now we can say all. So again I'll check whether I have drawn all. So bases A, B, C, D is drawn. Bottom base 1, 2, 3, 4 is drawn. A1, B2, C3, D4. That means all the edges are drawn. So thus this projection for the square prism for given condition is done.